Welcome to a lesson with Dr. Powell. Let's take a look at how we might factor this particular polynomial and use that factorization to solve. This is an equation right here. X cubed plus 9x minus 10 equals 0, and find all solutions, both real and complex, which means imaginary. So maybe there's some imaginary solutions as well, or complex, meaning there's a real and imaginary part. Okay, well, let's proceed. First, we use the rational roots theorem to list out our potentials. So factors of this divided by factors of this over here, 1. So we're going to have, it looks like just factors of 10, really. 1, 2, 5, and 10, plus or minus. Okay. Let's use Descartes' rule of signs. So if we were to put in, let's see, we see one sign change for right now, currently. So that means there's, well, for sure, there's one positive x-intercept. Now, what about negative x-intercepts or negative zeros? So for that, we replace all x's with negative x cubed plus 9 times negative x minus 10. Notice this becomes negative 9x. This right here, the negative comes out of the cube, so negative x cubed. Notice there are no sign changes, which means there are 0 negative x-intercepts. Well, that was nice. We just eliminated that whole bit right there. Very nice. Okay. Okay, why don't we just try something like 2 perhaps, maybe. Okay, 2, let's see, 1, and we have to skip. Okay, 0, 9, negative 10. All right, I put that 0 in because there's no x squared there, but I need to keep that there. There's nothing there. So we drop the 1, we have 2, 4, 13, 26. Okay, it looks like we have positives. Hey, wait a minute, that means 2 doesn't only work, but it's too big. Huh, we only have one thing left to try. Okay, so we use the upper bound and lower bound. Oh, we used the upper bound theorem. We didn't really need to use the lower bound theorem because we knew that from Descartes that there were no negative x-intercepts. So really we just have one thing to go after. All right, so let's try it. Okay, let's put 1 in now. In fact, why don't I just do it right here? Okay, let's just put 1 in. Okay, so we put 1 in and we get 1, 1, and then we get 1, 1, 10. Oh my goodness, we got it. That's awesome. Man, we even see how this factors. So we get the divisor will be x minus 1 multiplied by that quotient. So this actually factors as x minus 1 times x squared plus x plus 10. This is awesome because we already know one of the solutions. If we set this equal to 0, either this factor 0, that factor 0. When this one's 0, it's pretty clear. X is 1. That's one of the solutions. Now to get the other solutions, we just need to solve this as an equation right here. Now there's 2 ways of doing this. We could use the quadratic formula, or we could use complete the square. When we set this equal to 0, this actually, if you look at it, will not factor. So sometimes when things don't factor, we need to use one of the other options that we have. So let's go ahead and see what we can do with that. Let's go ahead and factor, or not factor, but maybe use, let's do both. Let's do a quadratic formula. First quadratic formula says -1 plus or minus. So quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So using that idea, we have b would be, so we're down here doing 1, 1, 10. So b is 1 and a is 1. So so negative b plus or minus, and then we have b squared, which is just 1. And then minus, looks like we have 4 times 1 times 10, so minus 40. All over just 2a, so 2 times 1, so 2. So it looks like we're going to get negative 1 plus or minus the square root of negative 39, which we can write as square root of 39 times I. That's another way of writing it. All over 2. Okay, so these would be the two solutions, x equals. Let's see how we would do this if we didn't remember this formula, how we could use complete the square technique, which isn't really too bad. So let me just kind of box out an area here. But we know that right now we have this as a solution, and we actually have two solutions here with the plus or minus notated. Now complete the square. Suppose we have x squared plus x, and let's just put the 10 on the other side, subtract over. Now here, let's replace this with, so notice we have a coefficient of 1 here, then we can just do a replacement. Otherwise, we would divide out by it. So making a replacement, this is x plus half of this 1 here, so just x plus a half, quantity squared. But then we also have to subtract off this 1/2 squared, so minus a fourth. Okay, so we subtract that off because that's what we had right there. This 1/2, and actually plus a fourth is what we would need in order to make this equal to that. Okay, so we're here, we subtract that off, we could just add the 1/4 over to the other side. And you can think of this as being like negative 40 over 4 if you wanted that negative 10. Just imagine it being negative 40 over 4. And that allows us to work with this a little better when we add over, because so we have negative 40/4 over here, and if we add over a fourth, we'll only have negative 39/4 over here. So negative 39/4 is going to be equal to x plus a half squared. So to get this, we take a plus or minus square root of both sides, and we end up getting so x plus a half is equal to plus or minus the square root of negative 39 over 4, which we could actually rewrite as square root of positive 39, but then times I. We can rewrite square root of negative 39 that way, all over, and then square root of 4 is just 2. Just remember we have a plus or minus. Then if we subtract over to the other side, notice we actually get this after adding fractions. You can check. So we get x equals negative a half plus or minus square root of 39 over 2 times I. So we get this. So we could just basically say this and this, which is the same thing as we had over here. So I just illustrated both ways of doing it. You could use quadratic formula, or you could complete the square. But in either case, we end up getting 3 different solutions, complex and real. And however many solutions we get in totality, after we work this all out, should be the exact same as this leading degree right there. Degree meaning the exponent of the leading term. That's called degree. Thanks for watching.